to the distribution function. Both the density and the distribution function, just to recap, are constructs, are generic general constructs in the world of probability theory, random variables, that are names for the collection of the probabilities that characterize our system. If you know the probabilities of a random system, you know all that you can know, and you can extract anything from that. That's the idea. So we need some names for those probabilities. And the first name you met was the density function. The distribution function is defined by the density function in that it accumulates probabilities up to and including what you plug into it. So it's a kind of, from the left side, cumulative probability function, right? So it takes, if I'm gonna, the formal notation is capital F, we use small f for the density, capital F for the distribution function. It's defined as a probability, that's one way of seeing it. It's the probability of going below or equal to 3. So the question I just answered before was the probability function evaluated in 2, because that was in the outcome 1 or 2, right? Maybe we'll even see that in a sec. And the more complicated way to express it is 2. Sorry for the few Danish letters there, I missed those ones. The probability of all of those to the left of what you plug in, including the one you plug in, you could say. That's the distribution function. Well, as I thought we'll get back to that, I asked that question just a second ago. What's the probability? Now with the fair dice, though, let's think about the fair dice, as it says. What's the probability of getting less than 3? Here we have to be cautious now, at least today, and then next week we can be sloppy again, which I like a lot. But today we have to be strict on the equality signs, whether they are, and the less than or larger than signs, whether they are, as we say, strict or not strict. Do we have the 3 or the 2 including or not, right? So when we say the probability of getting below 3, as I asked before, it corresponds to the probability of being less than or equal to 2, right? Because we have a discrete sample space, to be formal about it. We can see only 1, 2, 3, 4, 5, and 6. So less than 3 corresponds to 1 or 2, that is less than or equal to 2. We have to be exact about that to get the answer right. Which is then, by definition, the distribution function, which we could find, of course, by finding the sum of the 2 density functions, which would then be the answer that any one of us could have come up with without all this formal writing. Then, of course, it's just 1/6 times 1/6, which will become 1/3 in that case. I'm just trying to now to convey to you that we have these general constructs of densities and distribution functions as names for such collection of probabilities for our systems. What about larger than or equal to 3? Well, then we can, if we want, we can turn it around and express it. To be larger than or equal to 3 corresponds to being 1 minus less than or equal to 2, right? We can take the complementary event. Because if we want, then we could express even that probability as a function of the distribution function, which then again could be, now we found it before. So you should play around with that. This was the general part, actually. Density function, random